Hello, ladies and gentlemen. So now we're going to do this example. This is going to be the first example when we're actually going to calculate a probability, uh, associated with a normal distribution that occurs in a real example. So let's start. So suppose that Chantal's Boulangerie produces baguettes with a weight which follows a normal distribution with mean 20 grams and standard deviation 2 grams. What is the probability that a loaf weighs less than 17 grams? Okay. The first thing I want you to realize is that we know that the weight of the baguettes made at Chantal's Boulangerie follows a normal distribution, but not the standard normal. It follows a normal distribution with mean 20 grams and standard deviation 2 grams. Or in other words, the weight is a normal distribution with mean 20 grams and standard deviation 2 grams. Okay? I want you guys to be comfortable with this notation. And here I'm using W to represent the weight. Okay? And of course, this makes sense. When you think about a lot of real life activities, there's randomness. The weight of a loaf of bread will never be exactly the same from one loaf to another. The amount of the weight of the chips that are in a bag of chips, they will not be perfectly the same from bag to bag. Each chip will have a different size. Companies will try to approximate having the right average amount per bag, right? So when you buy a bag of, like, let's say, brand X of potato chips at the store, it might say 16 ounces, but maybe it's 16.01 ounces, or maybe it's 15.85 ounces. And so you can look at the weight of a baguette in the case of the example we're working on here, or the weight of chips in a bag, or lots of other measurements, to be honest, as random variables. Okay. So now we know this, and now what else? What are we going to do next? As you might imagine, we're going to draw a picture of what this distribution looks like, so that we can figure out in our brains a mathematical translation for how we're going to solve this problem. Okay, so they tell us it's normal with mean 20 grams and standard deviation 2 grams. So what does that mean? That means that it's a normal distribution, so it's going to be bell curved, right? It's going to be bell-shaped. We know that the normal curve is symmetric about the middle, and what is in the middle? The mean. So the mean would be right here, right? And if we wanted to, we could like figure out, like 20 minus 1 sigma, which would be 20 minus 2, which would be 18, minus 2 again 16, minus 2 again 14, etc. We could go this way, 22, 24, 26, and that would be the way that the distribution would look. But for us, if you think about those numbers and you look at the number we have here, what is the probability that a loaf has less than 17 grams? 17 will not lie on those lines. So for example, we might have thought, I could have tried the empirical rule. We can see that that's not going to happen. 20 minus 2 is 18, minus 2 is 16, so 17 is right in between. But that's exactly why we learned how to use the standard normal table and finding the areas under the curve. We're going to do that here. So visually, what is the probability that a loaf weighs less than 17 grams? Well, where is 17 in relation to the 20? It's over here. Okay, let's say that's 17. What is the probability that the loaf weighs less than 17 grams? It's the area under the normal curve here, under the normal curve here to the left of 17. Okay, so then we want to ask, can we find this out already? So if you're using a calculator or a spreadsheet, you could find this out already. But for us, we've been using our standard normal table. So what we're going to do is we're going to use the z-score formula to translate this value of 17 into the corresponding z-score, which will have the same area to the left on the standard normal curve as the 17 has on this standard random variable. So just to recap, what is the z-score? The z-score of a particular value of x will be x minus mu over sigma. And we recall that what it measures is how many standard deviations a particular value, which we have denoted x, how many standard deviations that value x is away from the mean. Okay, in this case, our x will be our 17, our mu is 20, and our sigma is 2. So let's calculate the z-score of 17. The z-score of 17 will be, let's write that out from x minus mu over sigma. That will be 17 minus mu. Our mu, remember, stands for the mean. 20 divided by 2. Okay? Now we can calculate this with a calculator if you want. Now 17 minus 20 is negative 3. Negative 3 divided by 2 is negative 1.5. Okay? Let me put that in the calculator just to verify. Yes. So now, if we were to, so what we can see is that, for example, underneath the line here, I've put the values for W. But for Z, for example, the Z score here would be negative 1.5. So, and of course, if this was and if I were to take the Z score of 20, that would be 0, right? So the corresponding value of 17 in the standard normal table, in the standard normal, would be negative 1.5. So we can translate our desired quantity, the area on the normal curve of the weights of the baguettes of Chantal's bakery, that are less than 17 grams, to the area under the standard normal curve that are less than negative 1.5. And we're in luck, because that's exactly a value we can just take away from the standard normal table. We can just read it off of the standard normal table. So we go to our standard normal table, okay, and we see that at negative 1.5, the value to the left of it is 0.0668. Okay, so this value is 0.0668. Okay. And so we can summarize our result as follows. The probability that a baguette from Chantal's Boulangerie weighs less than 17 grams is 0.0668. Okay. Now, okay. So now I'm just going to briefly recap the overarching picture of what we did and how we're going to approach these problems. The way we're going to approach these normal distribution problems, where we want to find the probability that something is occurring, is that we're going to draw our normal distribution. We're going to label and sketch the region of interest to us. In this case, we had to sketch the region, the weight of the baguettes being less than 17 grams, and we sketched it in like this. Then we used the z-score formula to find the value of the standard normal distribution that has the same probability, that will preserve probability values, as we're going to use the z-score formula to transform the values from the normal that is of interest to us to the standard normal value that will have the right probability properties. That's a better way of saying it. And then from there, we're going to use the standard normal table to find the desired area under the curve. In this case, since we were looking for the area to the left of, we could just read it off of the standard normal table. But of course, as you're going to see in our future examples, we're going to have the area between some region, the area greater than, and we've seen examples of how to do that with the table beforehand. And then finally, we're going to state the conclusion of our problem verbally so that we can appreciate what we were doing. I hope you've enjoyed this first example, and I look forward to seeing you again soon. Thank you so much.